All right, thank you. Good afternoon. Sorry we had to start 2 minutes late, but we had to get some new cables in here. Thank you all for showing up and coming instead of standing in line to wait for buy service devices or quickly go back to the hotel and watch the conference semifinals of the NBA, which will start in 45 minutes. So what we're going to talk about today is developing and managing a BI semantic model in SQL Server 2012 and everything that came after that, because we had a full SQL Server release not too long ago. And after that, we had a Service Pack 1, we have cumulative updates, we had Excel 2013, and in the meantime, all our code changed. So I did the same session last year, but we, in the meantime, changed a whole lot of things. So I'm going to talk about those things, and I'm going to go a little bit more in depth now that the tools are out for about a year. I'm going to go talk a little bit more about tabular models. What does processing mean? What happens under the covers? And how does the data get stored? So we're going to look at all the tools from SharePoint all the way into SQL Server Management Studio, Visual Studio, and back into SharePoint. And the last thing that I'm going to show you is something that is brand new, and I'm going to show you that in the end. I hope it all works because I have to remote back into Redmond machines. It's all scary. So we'll see if it works, but I think it will. Okay, so my name is Casper de Jonge. I'm program manager at the Analysis Services team out of Redmond for about 2.5 years. And today we're mostly going to be demos. Although it's a little bit changed, we're going to add a few more slides, but still it's going to be mostly demos. Before we continue, I want to spend a little bit of time to talk about the analysis service momentum. Who here is a multidimensional developer? Okay, a handful. Who here is already working with tabular models? Okay, even more than multidimensional developers. And who here has stopped working multidimensional and went just only tabular? Okay, one. Okay. Who here uses Power Pivot? Okay, yeah, a lot of people in the room. So one of the things that I want to highlight as well, with SQL Server 2012, we changed around our analysis services stack. And why is that? Well, not because multidimensional wasn't popular. I mean, multidimensional is the broadest adopted BI tool out there. It's the highest adoption rate, most widely the BI tool according to the Gartner Magic Quadrant. It is chosen for its low total cost of ownership, and it gets the highest rated infrastructure and for its development tools from all of you. And that is what Gartner asks all its customers. So analysis services is being used very broadly. But up until SQL Server 2012, it was mostly for SQL Server multidimensional cubes. And multidimensional cubes are pretty hard to figure out and to learn. And so my background was a multidimensional consultant. For years, I did that. Build cubes, build reports on top of that. And this is how I made my living. Then I figured out there's something called Power Pivot. And I really loved it. And I managed to work myself into the analysis services team, and now here I am. But with SQL Server 2012, we tried to close the gap between analysis service multidimensional and Power Pivot models. So we introduced the BI semantic model. The BI semantic model is built on the strengths of what we've been doing for 15 years. But we want to expand this to reach a much broader user base. Multidimensional is pretty hard. You need to know things like measure groups, unary rollups, dimensions, attribute relationships, hierarchies, all those things you need to know, and you need to know them well, because otherwise your cube is not going to perform. So what we want to do is we want to bring the simplicity of Power Pivot to the server, to the engine. So we want to embrace the relational data model. And that is what Tabular does. Instead of embracing the multidimensionality of measures and measure groups, we just have tables and relationships in Tabular. This is well understood by developers and IT pros because they've been doing this for years and years in the SQL world. So we've tried to bring those two together into analysis services under a single unified BI platform. It will provide flexibility. You can choose which way you want. And it supports the diverse needs of the BI applications. So you want to do MDX, you want to do multidimensional, go ahead. You want to do DAX, you want it to be quick, up and running, everything in memory, go ahead, it's a tabular model. For your client tools, it doesn't matter, because you can do either way. Together, that brings up the BI semantic model. So one of the core things here is we want to make sure that there is one BI semantic model, and not just across analysis services, but across the whole SQL Server BI stack. I mean, if you go back into the past, you have reporting services, which had its own report builder, its own semantic model. You go to Performance Point, they have their own model. Microsoft is very good at creating multiple things that are actually the same. So what we've tried to do here is say, across the board, if it uses BI, if you want to build a BI model, you're going to go through the analysis services BI semantic model. You see it happening. Power View now runs on top of the BI semantic model. Excel uses the Microsoft BI semantic model. Things like GeoFlow, which you saw in the keynote, under the covers, it uses the BI semantic model. So the data is living inside our BI semantic model. It lives everywhere across the board. And we want to try to maintain that. So it's for reporting, analytics, scorecarding, dashboarding, everything you can name. We want to be our model to be underneath that. It's for all users, personal, team, and organizational BI. And we'll come to that in a second. It's one model for client tools. And two ways to build it, tabular and multidimensional. And what that means is, when I build a tabular model, I can send MDX queries that Excel uses to it, and it just works. I can send DAX queries to it that Power View uses, and it just works. So two completely different query languages. Those are both supported. And probably you all have heard about this, but as of last week, with SQL Server 2012 SP1 CU4, you can now also send DAX queries against a multidimensional model. So you can now do Power View on top of multidimensional models. I have a complete session about that on Wednesday. It goes into much more depth. So what did we do with SQL Server 2012? Three major investment areas. We released version 2 of the Power Pivot for Excel 2010 add-in. We created a BI IT Pro toolset for BI professionals. And we released SQL Server Management Studio for IT professionals that actually works on the tabular models. After that, we came Office 2013. So Office 2013 came out. Now we actually integrated our BI semantic model inside Excel. So with Excel 2013, when you install Excel 2013, our analysis services engine comes with it automatically. So the BI semantic model is integrated in Excel 2013, and it's integrated in Office 365. You share your workbook up to Office 365. What actually happens under the covers, the workbook is going to be the database file, the analysis service database file is getting extracted and loaded into analysis services that is running inside Office 365. So our engine is running in a whole bunch of places. One other thing that is very important for us is that we have a seamless transition of the BI semantic model across the BI spectrum. And this is where I think is one of the key differentiators for Power Pivot and analysis services against our competitors. What we are strongly believing in is, in my world, before Power Pivot came out, I used to be the BI professional, and I was building the data model in multidimensional. And I had a project. This is what I needed to do. But every day I had people at my desk asking, hey, I need this information. Hey, I need this information. Hey, I need this information. But I couldn't help them all because otherwise my project will never finish. So if I say no, what happens? They go back to their workstation and think, okay, how can I get this information? I'm going to use Excel. I'm going to use Access. I'm going to use all the tools that I have at my disposal to try and get this information. IT doesn't have a clue what is going on. So what we want to do is empower those business users to find their information themselves. So it's a BI solution that's created by a user. The context is for a user, and it only exists as a document. So this means my boss comes in my office and asks me, hey, I want us to get this information for my meeting tomorrow. I couldn't find it anywhere in my corporate BI environment. Please give it to me. I fix it. I give it to him. 2 days later, the Excel spreadsheet dies away. It never touches it again. So this is what we call personal BI, my context. But as soon as someone starts sharing this information with his coworkers on SharePoint or Office 365, we call this team BI. It's our context. It's a BI solution created by a power user, but it's shared with people in his team. It's small teams, but it's managed on a server, so they can go on there and do managed data refresh and things like that. But the biggest problem here is there used to be no oversight. I mean, we didn't know what was going on. With sharing it to SharePoint, you can actually, as IT pros, go in and take a look and see what all your users are doing. What kind of workbooks are they using? This particular workbook that this girl created on the hall is now actually being used by everyone in the organization to base our revenue off. Oops, we probably want to check what she's actually doing. We want to make sure that this is our single version of the truth. So we can see that my entire organization is now using this Excel spreadsheet instead of the models that I, in my IT organization, have built. So what you then can do is take up that workbook and move it over into a corporate BI world. It's the organization's context. It's a BI solution created by IT. It's established corporate context. So we make sure that revenue actually means this times this times this divided by this. This is the way to calculate revenue. It is reusable. It is scalable. It's backed up. I mean, if the Excel file is deleted, it's gone. I mean, IT makes sure that everything is backed up, and it has a SLA. So it now is turning into corporate BI. But you only want to do that for the things that are being used every day by everyone. It is used for information across the board, not for an information spike where that lives for just 2 weeks and then dies down, because that is very costly to start a project for. So one side, we empower the business users. On the other side, we aligned with corporate IT. And with the Tabular model, the BI Semantic model, you can go from one side to the other side pretty easily. And that's what I'm going to show you today. So what are the advantages of corporate BI over Power Pivot? Scalability. There are things like partitioning. So you can create partitions in your model, and I'll show you why you want to do that later on. There's something called direct query, which used to be only available against SQL Server databases. It is now also supported against PDW databases, PDW v2. And I'll show you a demo of that later on. So you can do a dynamic pass-through, like roll-up in multidimensional. You send a DAX query against the Tabular model. Tabular model automatically transforms that into a SQL query, and it pushes it down without even storing it in memory. So you can use Power View directly against your SQL database or PDW. It is manageable. You can use SQL Server Management Studio. You can use AMO, which is our programming language. You can use PowerShell. You can use SSIS packages. Like, for example, your ETL flow has finished, and you want to say, after all my data has been loaded in, refresh my cubes. You can do that using SSIS. You can add security, and I'll show you all of that. You can add security to your Tabular model, saying you can only see one part of the model, and you can see only the other part of the model. You both cannot see everything. And developer tools for the developer. Visual Studio, it is integrated source control, it is team build, it can use deployment wizards, so it's the not Excel that you can use. So what is the difference between those two design tools? On one side, we have the personal BI we call Power Pivot for Excel. It feels like Excel. It is Excel. It is one file. You can save it online. You can save it to disk or to SharePoint. It is for rapid response to business problems. It is optimized for Excel power users. Its solution lives for weeks and months. On the other side, we have SQL Server Data Tools, formerly known as BIT. It feels like Visual Studio. It is Visual Studio. It is a project. There's a business case. There's a budget. There are dates. It's optimized for BI pros. It can take larger data volumes. It's a team building BI solutions. Although we're not optimal for that yet with Tabular, but I mean, the tools support it. And you can use deployment scripts, versioning, source control, TFS. All of that is supported. And that is the corporate world. Okay. Enough slides. Let's go into demos. So the first thing that I want to do here is we have in our organization deployed Power Pivot Excel 2013 to all my end users. I know it's a little bit early to already have deployed Excel 2013 to everyone, but in our Contoso world, we have done so. We have rolled out SharePoint 2013. People can share their workbooks across on SharePoint. This, by the way, almost everything that I'm showing you here will also work for SharePoint 2010 and Excel 2010 with the Power Pivot added. So there's nothing here that is new for that. So in my case, I'm an IT pro. I work at Contoso Communications. I have given out Excel to my end users. They've been playing around, and every now and then I'll go into my SharePoint admin portal, and I'm going to look at my Power Pivot management dashboard. And there are a few things that you can see here. You can see the infrastructure. You can see the average CPU usage, the average memory usage. And that is all nice, but it's infrastructure. I don't necessarily care about that. The most interesting part is here down here. It's the workbook activity chart. And this workbook activity chart gives me an idea on what is being used by my organization and how it's being used. So and actually has a play axis. So what you can do here is you can play it out. You can see that this workbook is being started to be used more over time. So you see it going to this direction. This means it's going to be, there are a lot of queries, but it's still not the same users. So if you see a workbook going all the way up to the right corner and it stays there, it means people are using this day in, day out. Because what we currently expect, and let me run it again, you can see this guy, for example, was used for some time, but it dies down again, right? Here it goes. It goes away. And that's what we expect. We expect workbooks to be used and die down. Used, die down. And you should be able to see that for a long time. If something sticks, something is being kept in there, you probably want to take a look at it. You probably want to investigate what is going on. Because that might be a perfect candidate to bring over into the corporate BI world. Another thing that you might want to see here is you can see the workbook activity list. Another interesting thing what you can do here is a workbook activity. So the interesting thing is all the data that we're showing here is actually stored in Power Pivot. So we actually created a Power Pivot workbook that we put inside SharePoint, and that is going to be refreshed each and every time. This Power Pivot workbook you can use to query against. So you can see what data sources have my coworkers been using. This database that we have here is going to migrate it to, and we're going to call it to something new. Who has been using this database? Everything is accessible in here, and you can see that. As soon as they start sharing it to SharePoint, it becomes available for everyone who has access to this workbook to browse and to see what they're doing. Who's using it? What are they using? When are they using it? And it can gain you a lot of information. Where are they getting their information? I mean, I'm seeing this number and these dimensions in my report, but I thought these were not accessible to anyone. How did they get them? You can find all of this information in here. In my case, what I want to do is I want to bring one of the Power Pivot workbooks that I have in my Power Pivot gallery that I uploaded to SharePoint, and I want to bring that in. Here, this is the workbook that someone created inside SharePoint, and I want to bring that over into the corporate IT world. This is the workbook that has been used too much, and I want to bring that over. So that's what I'm going to do now. And I'm going to start by, one of the requests that already came in is, this particular workbook is to solve one particular problem. But I want to see more than just 1 year. So only this thing contains only 2010. I want to have all the years in here. So I'm going to add that feature request, and I'm going to solve that. So the first thing that I'm going to do is I'm going to connect to my analysis services database, SQL, with SSMS. And here you see 4 different flavors of database that are connected to. The first one is a SQL Server database. The second one is Power Pivot for SharePoint instance. You see these little icons. The third one is a multidimensional instance. And the fourth one is an Analysis Services Tabular instance. So you can differentiate them by looking at the icon. And if you have SSMS installed from Service Pack 1, we've added a new feature here, small feature, but still, where you can see the information about an instance. So you can see the name, you can see the supported compatibility level, and we'll come to that in a second. You can see the server mode, and you can see the version of it. So you can connect to Analysis Services, you can say, what is the server mode running in, and what is the version of the database running into. Let's continue by looking into what my demo laptop is. The first thing that I want to do is, I want to get this Excel workbook, and I want to upload it to my server. I don't want to start creating a project, I just want to get my end users up and running. So the first thing that I'm going to do is right mouse click and choose Restore from Power Pivot. So I'm going to restore it instead of a normal database. I'm going to restore it from a Power Pivot workbook. I'm going to click on it, and I quickly copy it. Okay. I'm going to press OK. Now, what this is going to do, it's going to extract the workbook, the Excel workbook. There's a hidden backup file from Analysis Services in there. It's going to extract that and restore that to the database. I'm going to refresh. You will now see we have a customer profitability database inside on our Analysis Services tabular model. So now we have an instance running on a server, a proper server, which we have full control over. We can do whatever we want. So if you go in here, what you can see, things are very different like what you were used to in multidimensional. In multidimensional, you have things like data sources, data source views, cubes, dimensions, measures, groups, all of those things. In Tabular, it's a much simpler world. We have connections. You can open up the connection. You can change the connection strings and reprocess and get data from somewhere else. You can change the impersonation information. But there's just two things. There's connections and there's tables. That's about it. And you can add roles and security. And we'll come to that in a second, in the later demo. And of course, I can query it. So let me open up a query file. Make sure everyone can read it. So I've connected to my customer profitability that I just uploaded. And there are two things that I can do here. I can send an MDX query. Boom, will give me the results. And I can send the same query, but now in DAX, to the same database. And I get the same results. So one database running in Analysis Services can take two different query types. So we want to make sure that however you connect to Analysis Services, you will get the right information. You don't have to do anything special if you connect to your Excel 2007 will even work against the tabular model because the MDX is still the same. But if you use a new Power View, which came out with SP1 or with SQL Server 2012, you can also run that against your tabular model. So your client tools can stay the same. Pro Clarity will work against the tabular model. Okay. Another thing that I can do is I can go in here and do browse. So I can do total margin by year. And now we see the total margin, it's only for 2010. So what I want to do is I want to add more years. And I'm going to do that by adding a partition. And different to other tools like SQL Server and even multidimensional world, partitioning doesn't have any effect on query performance or anything like that. Partitioning is just for manageability of loading in the data. So imagine that you have a 2 terabyte tabular model and you want to add incremental data every day. You don't want to load 2 terabytes of data every day. You just want to load that particular delta between what you already have and what's new. So what you can do is create a partition by saying, only give me the data for today and add that to the model. So what I'm going to do in this case, I'm going to add the history. I'm going to go to partitions, right mouse click on the table, make it a little bit larger. I'm going to copy the current partition, which is the Every table has a partition. And the interesting thing here is, different to multidimensional, where you can only have partitions on measure groups, in Tabular, you can now create a partition on every table that you can think of. So we don't have that anymore. By default, it automatically creates one partition, but I can copy this partition, and it takes a new query. So what I'm going to do is, I'm going to do select star, underscore history. I'm going to point to a different view, which contains my history information. Press OK. I'm going to press process. And here you can see there are a few things. I can choose a processing mode, and we'll come to that in a second, what these all mean. And I can script it out. So I can script out what I'm doing right here into an XMLA window, and I can copy this code, and I can use this code wherever I want. I can write custom software that triggers this. I can use SSIS. I can use a SQL Server agent job that I can use this XMLA to trigger on my own automated process. I can use this XMLA as the basis of writing custom code that automatically creates a partition every day, automatically generates the SQL query that is there, and start processing it. All those things are possible. So the first thing that I want to be able to do here is process it, and I'm going to choose process default. I'm going to press OK. And while this is doing, it's not going to take too long, but I'm not going to have you wait. We're going to go back to the slides, and I'm going to show you a little bit more on what it actually means to process data in tabular models, what it actually means to get data into analysis services tabular models. And probably you're all familiar with the way that data is being stored inside analysis services tabular and Power Pivot. Everything is in memory. But what does that mean, everything is in memory? So what happens is, imagine in this case that I have a table 1 with 3 columns. Column 1, column 2, column 3. The data comes from a data source. Data starts to be reading in. What happens in that case, the tabular model and Power Pivot, this goes for both, will create two things, a dictionary and column segments. And what it will do is, it will look at all the data inside the columns, and it will see what are the values. Let's say it has 2 values. One is A and one is B, and then the third column comes in again, with the value of A. What it will do is, it will only store the value A once in the dictionary. And the others are pointers in the column segments to that dictionary. As you can imagine, storing a pointer in memory is much better for memory consumption than actually storing the real string values. So this is how we optimize the information in memory. And also, being able to sort and filter and all of those things over integer values, pointers to the real values, is much faster and much better performance than actually working with the actual string data. So what we do is, we read in the column segments and we add data to the dictionaries. We actually read in multiple segments. It would be too bad if we were to load all the data from 2 terabytes all in at once, and then have to segment and everything only one time. So what we try to do is be smart and read chunks of data, about 8 million rows, read chunks of data, and then start working that in the meantime. So another interesting thing that you can do inside Power Pivot and tabular models is a concept called calculated columns. You can create a calculated column inside Power Pivot and the tabular models, and calculated columns are DAX expressions that are being stored, as it were, if they came into the model. So the function is going to be executed for each and every row inside the table, and the values are going to be stored in memory. So when someone uses it, it's different than, for example, in multidimensional or in a DAX measure, where they get evaluated when you use them. Calculated columns are stored in memory, so they only get recalculated during processing time. So when you use this, it's going to be blazing fast because the data is already in memory. It doesn't have to be pre-calculated. So they're stored like any normal column. There's no differentiation. Under the covers, we create hierarchies. Hierarchies of the data. And this is different than the hierarchies that you see in front of you in the tools. This is a hierarchy that we create under the covers, because we want to know if you drag in products, we want to know how you want to order them. By default, we'll order them alphabetically, but you can choose a different order. For example, you want to see January, February, March, April. You can set that sort order in the tools, and we want to make sure that we can give that back to you. Also, because under the covers, we support both MDX and Tabular, we need to have a hierarchy for MDX to work. So we create hierarchies under the covers as well. They provide quicker access for querying. We have a second table, table 2, with column 1 and column 2. We create a relationship, and in the original table, we will store a pointer to the second table, because then we know how we can fast access data from the second table when you want to do joint queries, which most of the queries will be. There will be joins between two tables. And we want to optimize everything that we do for query performance. You can create partitions everywhere. Partitions are groups of segments, and they're intended for data management, as I said before. You can have partitions on any table. Yeah, the partitions are only for segments of data. So what actually happens when you run? So this is a screenshot that we took from actual during processing time of, I believe, a 2 billion row table. What happens here? Well, in this case, you see a lot of interesting spikes. And you see a big CPU spike in the middle somewhere, and a few more. And network is also loading up pretty quickly. So what happens is, we try to be smart. What I just said about segments, we actually do it a little bit differently for the first 2 segments. Because we guess that most of the Power Pivot and Tabular models will be less than 16 million rows. So because we think most of them are less than 16 million rows, we will read the first 2 segments together, because that will be much more efficient when loading in the data. When it turns out they're actually more than 16 million rows, we will split them up again in 2 different segments. So this is an optimization trick. But you can see immediately what happens. We read 2 segments, and you see a big spike in networking traffic. So we're getting the data over into the Tabular model. You see memory going up. And CPU is kind of on the same. Nothing really happens. It's just reading data. The next step is, in this case, it's going to split. So you see, boom, a big spike. We're now splitting the segments into 2. In the meantime, after reading segment 1 and 2, we'll start reading segment 3. While we're doing that, we start compressing segment 1 and 2. So we try to be multitasking here. And this is why you see this big CPU spike here, because compressing the data, it loads in the data in memory, and then it starts looking at all the data and starts compressing it. So this is a heavy CPU task. And we try to do reading and encoding together with compressions. We never want to do multiple compressions at the same time, except for the first segment. After that is done, we start compressing segment 3. And after that is done, we start doing calculated columns, hierarchies, and relationships. And this is a typical of when you look at what Tabular model is doing under the covers, this is what is happening. So how does that relate to all the processing options that I just showed you? So I just picked up the same slide again. We have a few different processing options. We have process data. And this is the same as loading in the data and compressing it. That's it. Nothing else. So either your partition or your table will not be usable after this, because all the attributes, all the auxiliary structures are not built. But that is for a reason, and I'll show you that in a second. We have another thing that's called process recalc. And process recalc is the auxiliary structures. So imagine you have 3 different partitions. You don't want to do a process full on each and every of them, because those auxiliary structures need to be done at the end anyway. So it's better if you do 3 different partitions, do process data, and the last one, process data, and a custom process recalc. Because otherwise you'll be recalcing and recalcing, while you can only do that, you only have to do that once. Process default means we do process data, and we do process recalc if needed. So process default is often a safe choice. We will be smart enough. In some cases we will have it wrong, then processing will take a little bit longer. If you want to be really safe, you do process data and process recalc when you know things are right. Process clear will remove the data in a partition or a table. Process add creates a new segment and merges the other segments. So this goes a little bit deeper into the underlying covers. And we also have a process defrag. Imagine that you have been importing partitions for a month. Every day you do one partition. What we don't do is go back and check into this dictionary to see if there are values already added once before. So then you might have duplicate values in your dictionary. So if you do process defrag, what we'll do is we won't load any data back into the memory. We will just look at what is there in memory, and we'll start making optimizations. We'll start defragging the column segments and the dictionary to make it much more optimal. So if you do incremental processing, the typical is create new partitions for new data, do process data on new partitions or to reload into existing tables, do process recalc to rebuild calculated columns, hierarchies, and relationships. I don't know if any of you looked at these slides before this session, but these slides were not in there up until this morning. We have been uploading them, so if you download the new slides from today, you will get this latest slides, including this information. Avoid doing multiple process fools, because each causes a process recalc. Unless it's in a single transaction batch, then we will do the smart thinking, and we automatically do only one process fool. So, some advanced tips and tricks. Unfortunately, we don't support parallel processing. Tabular model does not support parallel processing of the same table. What we do support is parallel processing for tables, for multiple different tables. So you can create a single transaction batch and load in 3 tables at the same time. We do support that. We don't support multiple partitions of the same table at the same time. What multidimensional will do. We won't. So there's no parallel processing of a table's partition. Use process defrag periodically. Deleting partitions, all of those things will leave the dictionary in a reasonably bad state. It still works, but you can get better performance if you do defrag every now and then. Another interesting thing is remove unused columns. We often tell customers, when you load in data into memory, if you don't use a column, get rid of it, because it only takes up space and memory. But what often happens is they go into Visual Studio, delete that particular column, but forget that the column is also in the data source, in a query. So we will ignore it and not load it into memory, but the data will just still continue to come in, and we then, the analysis services, will ignore it. So if you want to remove bandwidth and loading of and extracting data from SQL and make that faster, also make sure you remove from SQL query. Merge partitions to reduce segment fragmentation. And in this case, what, for example, means, let's say I create a partition for each and every day. You don't want to have 365 partitions. What you probably want to do is, at the end of the month, club them all together into one month partition, and at the end of the quarter, club them all together in a quarter partition, and at the end of the year, create one big year partition, and maybe one big history partition. Because you're never going to do anything with them anyway. So just as well, make sure they're all together, and it's in a much more optimal way. The last thing is not really related to processing, but error handling. In multidimensional, you really have to go in and define your error handling completely yourself. If there's RI violations, multidimensional by default will give you errors and stop processing. Tabular won't, because RI violations are by default assigned to a blank value. No errors during processing. And there's also no way to enforce this in Tabular model. Okay, let's go back to some demos. So in the meantime, data has been loaded in, of course, because I've been speaking for a long time. When I do refresh here and execute the query again, you will now see additional data is being added. And if I run the queries again, you'll see additional data is being added. So I added this partition with new data. Okay, so that is SSMS. Let's go ahead and pick up this Power Pivot workbook and actually change that inside Visual Studio. So what I've done here is open up Visual Studio 2012, and this is the new SQL Server Data Tools for BI, which is the web downloadable. Then you will get SQL Server 2012 shell. By default, the box, if you install SQL Server, you will still get SQL Server 2010, because SQL Server 2012 release came different on a different timeline than before. So SQL Server when you install SQL Server Data Tools from the box, you will not get Visual Studio 2012, you will get Visual Studio 2010. Web download, today available. You install that, you get SQL Server 2012 and our templates installed. Another interesting thing, and I just want to briefly mention it, which is new with SQL Server 2012 SP1, when I create a new project, I can choose a few different types. I can choose analysis multidimensional, import from server, tabular models, import from Power Pivot, and import from server. In this case, I'm going to quickly check analysis versus tabular model. And when I do that, I get a new dialog, and it asks me for compatibility level. Why did we add this? And the reason for this is Excel 2013 came out in the middle of a release for us. Excel 2013 had a different type of tabular engine than SQL Server 2012 RTM. So we introduced the compatibility level for you to actually be able to import Excel 2013 workbooks into tabular models. If you wouldn't have done this, you would never be able to import Excel 2013 workbooks into a tabular model. By default, it's set to select 1100 models. This is RTM. If you change it to SP1, you get 1103. You don't see a lot of differences in here. There's almost no difference between the version to the user, to the eye. Under the cover, it's completely different. There's a lot of different things under the covers. It's an unfortunate choice, but that's the way we have to do it. So when you use 1103 models, you can only deploy to servers that are upgraded to SP1. You cannot deploy to an RTM server. If you want to deploy to RTM servers, make sure you select 1100 models. You can upgrade from 1100 to 1103. You cannot downgrade. So on one way, and we will warn you multiple times before you do that. Okay. So in my case, what I'm going to do is create a new project based from the Power Pivot workbook. So I'm going to use the same workbook that my end users created, and I'm going to import this into tabular models. In this case, my compatibility level is grayed out because it came from a Power Pivot workbook, which already is a model, and I don't have a choice. So if you import from Power Pivot, you don't have a choice what you choose. We will choose for you. Press OK. I choose customer profitability. Press OK, and we'll create my tabular project.
Question?
Yeah.
I don't know if you will show this, but the original workbook you imported just before, can you change the data source inside that and make the report continue to run?
Unfortunately, no. So the question was, when you import the workbook into tabular model, we want to keep the reports, but just point them to a tabular model. That is a very good question, and unfortunately, I have to say no. You cannot do that. We will work on that. I'm not saying a timeline, but yes, this pains me very much. So yes. So in this case, I imported it into Visual Studio 2012. It very much looks like Excel. It has the same functionality, the same look, and same feel, not the same look, because this is the light and dark theme of Visual Studio 2012. There are a few things. There are still tables here. There are still, same as in Power Pivot. There's one big difference, of course. You have a properties grid here. And again, I can go back into the properties grid, and I can see the compatibility level. The compatibility level is, let me zoom in a little bit. Compatibility level is grayed out because I cannot go back. I cannot downgrade. I can only upgrade. If this were a 1100 model, I could upgrade it to 1103 without a problem. The other interesting thing, what happens here is, so where does this data live? In Excel, we actually have an analysis services engine running inside Excel. In Visual Studio, we don't have anything like that because Visual Studio is a 32-bits application, which means if we were to run our engine inside Visual Studio, you will never be able to load anything over 2 gigs of data, which you probably don't want. So what we had to do here is do some tricks. So what we actually have is a workspace database. Make it a little bit wider. So we have a workspace database, which is a tabular, my project name _administrator_large GUID. the workspace retention, so what do you want to do? You want to unload it from memory, you want to keep it in memory, what do you want? And what's the workspace server? So what I need is actually having a, let me refresh this, you will see it come up. So you will need an analysis services tabular model running on your machine in order for you to develop Visual Studio applications. You can then install a developer edition of analysis services and you'll be fine on the dev machine. So what I can do here is, everything is available. I can do diagram view. I won't go into too much details on all the functions and features that are there, but things like hiding columns, hide from client tools are all available in here. So one of the things that is typical for BI Pro is where the difference is between the Excel user and the BI professional is the Excel user is just building his workbook for him. He just wants to get a number and a report out, and that's done. He doesn't care about what tables are being named, how it is accessible, if it's understandable to the users. As a BI professional, the obligation is you need to make sure that this data that you're exposing to all those users in the organization is actually understandable and usable. So there are things like renaming columns, makes a lot of sense, adding descriptions, creating perspectives. So I can create a perspective here that says test perspective, and I only want to see this table and this table. I can go down into individual columns as well and press OK, and I will add perspective. And I can use perspective in two different ways. I can go and analyze in Excel. I can click on and fake like I'm an Excel user, and click on this button and it will open up Excel. And actually gives me the opportunity to choose my perspective. Now I can see how my end users will see this report. And we see here is only the two tables. Or it's two tables and a measure group. But so I can do sum of usage, and then product, device type, and we're good to go. Let's see. Perspectives. And the other thing that I can do here is security. There are a few different ways to do security. There's a simple way of adding security. In this case, I can create a role that says role, read permissions, and in this case, I only want to see where dim political geography, country, or region is West. So what happens here is when I create a role, I can create a few things. I can create the permission level, read, I can process it, I can process it only, and I cannot read it, and I'm the administrator. In most cases, you will need read. And what happens down there is you can create a DAX filter for each and every column. So what this thing will do, there's a question? Excuse me, can you? So you can actually do that in Power Pivot as well. So the question is, I want to relate a date table to one date table to the same table with three different ways, like a sales order and a yeah. So it actually allows you to do that. I'll show you that later. But there's a thing that's called active and inactive relationships. So if you create three relationships between two tables, one is active and the other ones are inactive, you can use the inactive relationships in a DAX query, in a DAX measure, to create different types. It is not like in multidimensional where you have role-playing dimensions. So that is not possible, but you can create them and use them in DAX expressions. I can show you afterwards. So what happens here is I create a DAX expression, and this DAX expression will be evaluated for every user in this group that is connecting to the tabular model. And some people might ask, is this going to be fast? It is going to be fast because everything is pushed way down into our engine. But what will happen is that the user will connect to this table, and it will, for each and every row inside this table, see, does this column contain region West? Yes? Okay, good. Yeah, you can see it. Does it contain West? No? Okay, you're not allowed to see this row. The big difference between tabular models and multidimensional models here is, where multidimensional, if you wanted to use dimension security, if, let's say, for example, you drag in sales amount, you will always see all the sales amount. The security would only be applied when you put a member from the particular dimension into this group, and then all of a sudden the relationship, the security will be applied. In Tabular, it's different. When I put my security here on only region West, you will never ever be able to see anything else than West. So you won't be able to see the grand total. We don't have anything concepts called like visual totals, like what we have in multidimensional. You will only be able to see West. And let me show you in a second. So in this case, I've created this. I'm again going to analyze in Excel, and I can choose my role to test. Press OK. And now you will automatically see we have West. One other cool thing you can do here is, for example, one of the big things in our multidimensional models that we have is dynamic security. So what you want to do is, I want to have security that is not defined by me when I'm going into this tool, but is defined somewhere in the table, in the database. And I would just want to insert a row into the database, and then automatically, after processing, automatically it will work. It will automatically use those rules that are defined inside this table. I'm going to show you how to do that here in a second. So what I'm going to do is, I have a table inside SQL Server, and it's called security. And I have a region user table. And here we have two different, we have a West for demo user, and North for test user 2. So I'm going to use a DAX measure that will automatically use the values inside this column to determine the security, not have me having to hard code it in here. First thing that I need is, I need this data available in my model. So what I'm going to do is import it. Just like in SQL Server, just like in Power Pivot, just import data. Press finish. Just 2 rows, and here we are. The first thing that I want to do is start creating a new role. New role, dynamic. I'm going to give you read permissions. I'm going to add demo user as a member of this role. I'm going to use a DAX formula. And this is the measure that I'm going to use. What I'm going to do here is I'm going to put this measure directly into my tabular model, and it says, return all the regions where I'm going to look up value, which is a DAX expression, where region of my region table, this is my table that I just loaded in. The region table from region users table is where the username is equal to the current username that's logged in and connected to the tabular model. This is a function that we have. If you run this function, you will see the current user who's logged in. So the username is equal to the username that's logged in, and the region of the region users table is equal to the region of the current row in the dim political geography table. So this will automatically go through each and every row inside the dim political geography table and automatically check, does it exist in the other table? Does it exist in the other table? I haven't created a relationship between the two tables. I'm just using DAX to work around that and kind of use a lookup value to, this is like select region from region users table where region user username equals to username and region is region from the region dim political geography table. So I'm going to paste that in. Press OK. Ooh. That is bad. Okay, let's do it again. I've not seen that one before. So one of the good things that you can probably see right now is that most of the things are still here because when you save, it automatically persists everything, also in memory, but also on disk. Test, read, demo user. Now let's see if I'm pushing it by doing it again. Not sure what it was. Oh, well, I forgot one thing. Of course, what you want to be able to make sure of is that no one can actually read this actual table. You don't want that. So what I'm going to do here is equals false. We'll automatically make sure that for each and every row inside this table, it always returns false, so no one can see anything in here. Another big difference that I want to point out here is, different than with multidimensional, we don't support object-level security. In multidimensional, you can say, you can only see this part of the model, you can only see this part of the model, and you will never, ever be able to see the tables, even. Tabular doesn't have that. Tabular can always see all the metadata. You can hide the data, but you can never hide the metadata. That is impossible. You can use perspectives, but that is not a security feature. So everyone who's hacked out around a little bit with connection strings can work around that. So I wouldn't advise that. In this case, you can do is equals false here, and then you cannot see anything inside this model. Another interesting difference between multidimensional and tabular is when you create security on tables, it will automatically traverse to other tables. So when I would have created a relationship between region user and the dimpological geography table, that would have meant that all the tables would be empty because it automatically traverse the relationship. Just like what I told you before, is when you say the dimpological geography region is west, you will never ever to be able to see anything else from the different regions. It will automatically traverse the relationships. That is also very different than it is in multidimensional. Okay? So I cannot use this trick anymore because it wants to use my real credentials. And even this other Windows user is not fooled. So I need to do something else. So what I've done here is created a batch script that says run as Excel. So I'm going to run it as my demo user. And I'm going to start up as my demo user. You can see it on the top here. And I do data from other sources and other services. I'm going to connect to my tabular model. Press finish. Drag in sum of cost. And I do and again, now we can see west. So what I could do now is, for example, go in here, edit, make it north. So now I've changed the data inside the underlying database. Go back into my tabular model and say, process this particular table. 2 new rows. You see north now here. If I were to refresh my table inside Excel, you'll see it change to north automatically. So I only changed the underlying data source. I didn't change anything in roles and security. It automatically propagated through here. So when you make changes to those things, you process your table, the customers will automatically be connected to the new security method. Okay. So the last thing that I want to talk to you about is how do you connect using SharePoint? So what we have here is In SharePoint, we have a document folder, and in this document folder, we have a few different files. We have an RCS file, which has been there for a long time. An RCS file can be used to point against the tabular model. The most important thing is make sure you pick the right data source. In this case, you always need to pick Microsoft BI Semantic Model for Power View, not analysis services, because that goes through our old path. This goes through the new path and uses CSDL, which exposes a tabular metadata. So Power View will ask, dependent on what you choose here, do we need to go tabular or multidimensional? And Power View only understands a tabular world, so you need to choose the BI Semantic Model for Power View. This is actually a connection to a tabular, a multidimensional cube, or you can create a BI Semantic Model file, which is much more straightforward. You just give it a tabular model name. You say, what's the server name, and what's the database? So what customers now can do is they can just click on it, and it will automatically open up Power View against that model, and they can use it directly. One interesting thing that I do want to point out here is what you often have as problems when you're installing anything on SharePoint, and you want to point it out of the SharePoint server. In this case, what you probably don't want to have is your analysis services running inside the SharePoint farm. You don't want analysis services running together with SharePoint on the same machine. That is a bad idea. The biggest problem is as soon as you start installing things on different machines that are not running inside of the farm. Does anyone know the answer? Kerberos, exactly. You will run into Kerberos, and that is no fun. So what we actually do here is the BI Semantic Model file has some tricks up its sleeve. What the BI Semantic Model file does, it will try to connect to the analysis services database that is running outside of the SharePoint farm. When it's not an administrator and Kerberos is not set up, the machine on the other side will say, ooh, I don't trust this connection. Please go away. And okay, so it goes away, but it won't give up. It will try a second time. And the second time, it will actually try and connect as the service account that Power View is running under. And we'll use that to connect to analysis services. If you have set up analysis service correctly, in this case, being the service account that reporting service is running on can be an administrator on the Tabular server. We will make that connection now as an administrator, and we'll swap back to the original user that was connecting. So you can bypass the Kerberos issues. So we will make this connection using an admin connection, then swap back to the original user that was connecting. There's no way for the user to muck about with this. So we'll work around the Kerberos issues using you can actually also do the same thing with the RCS file, but it's a little bit harder. If you want to start enabling this inside document folders inside SharePoint, the one thing that you need to make sure of and you need to think about is you need to enable these things inside SharePoint. It's pretty frustrating when you open up SharePoint, you have installed everything, you think, oh, I'm good to go. Where is the RCS file? Where is the BI Semantic Model file? So what you need to do is go into the library, go to Library Settings, go to Advanced Settings, and say Allow Management of Content Types is yes. If you have done that, you can add additional content types like the BI Semantic Model table file, report builder, RCS data source. This took me like an hour of browsing on the internet. I was very frustrated about it.
This is available only in the enterprise edition of SharePoint?
So the question is, which version of SharePoint is available? Only Enterprise, yes, correct. The tabular model is also only available in the Enterprise version of SQL Server or the BISQ. Okay. So one last thing that I want to show you before we continue is we've made some additional changes to the tabular models to support PDW v2. Has anyone heard of PDW v2? Only one? So PDW, or a few more. PDW v2 is a new version of PDW that has just been released, and PDW v2 supports Polybase. And Polybase is a way that PDW translates SQL queries directly into Hadoop, into Hive APIs. So you can send queries against PDW. It's a structured way of, you first need to create a table, so you need to structure it, but the unstructured can point to unstructured data on Hadoop. You can point to that using PDW. PDW is Parallel Data Warehouse, which is another product of Microsoft BI. But yeah, so you can translate a structured query into Hadoop, and in that moment you will be able to query SQL to Hadoop directly without any caching. We've made efforts to make sure that the tabular model in direct query mode will actually also support the queries that are being PDW. Let me reverse it. PDW has made sure that they support the queries that we send. So in direct query mode, which you can put your analysis service tabular model, meaning not caching, we will translate the DAX as being sent to the tabular model into SQL queries. The SQL queries will then be sent to PDW. PDW will then use Hive Hadoop APIs to connect directly to the data source below it. So what I'm going to try and attempt is, using some servers that I have that we've set up in Redmond, is create a tabular model and use PowerView inside Excel 2013 to go through tabular models. This makes it a little bit easier to understand, maybe. Two tabular models, and this tabular model is going to send a SQL query to PDW v2, and PDW v2 is going to talk to Polybase, using Polybase directly to Hadoop. While you're looking at this, I'm going to see if my machine is still working. Probably need to log in back in. So what happens here is, you see all the third-party tools. It queries the BI semantic model, the tabular model using DAX. It uses MDX and DAX. In this case, only DAX is supported into direct query mode. It sends a SQL command to PDW, and PDW, of course, can choose. PDW also points to other data sources. But it's, for those of you who are not familiar with PDW, PDW is a traditional hub and spoke technology. It will make sure that you can scale out your queries over large amounts of nodes. So it's going to be for blazing fast, data warehousing techniques to allow queries to be returned fast.
Is that what was Yahoo?
No, then Yahoo was actually using traditional multidimensional cubes. Yeah. But that was something very special, I would say. So for those of you who are not familiar with that, is at Yahoo, one of our big customers, they are running a 25 terabyte multidimensional cube over Hadoop data. So that's pretty amazing. Let's see, I think it was number 8. Number 7. Okay, so what I have here is, this is my main machine. I've connected into our Microsoft IT corporate network. What I'm going to do is connect to a database, and this is my PDW database that we have running in Redmond. I'm going to connect to it and pray that it will work. It actually seems to be working. So what I have here is a database called NOAA, and this is actually a Hadoop database. So I took the Hadoop folder that is underlying this. This is the Hadoop. I used this folder is the folder that I'm going to point to. And I created a table that's going to point to this folder. And Hadoop takes care of the translations in between, what it means and how the files are being stored. I won't go into too much details about that. There are people at the booth who are very good in talking to you about PDW and Polybase. But this is the database that is on the covers. You see just a whole bunch of text files into an Hadoop folder. What you have done here is my daughter. What we have done here is created a table. And this is a very special table. You've probably never seen code like this, but especially not SQL code. What we have here is, this looks very normal. We created this table based on the information, the text files that we have down there. But under that, we have some additional extended PDW properties. Like, for example, you see it in the middle there, PDW external URI. It points to an HDFS and to that just folder that it just had there. This is where PDW is going to execute its values against. So PDW is going to translate the queries that come into this database, and it's going to execute it against the Hadoop folder that is down there. And it's going to, in PDW fashion, it's going to scale it out over a large amount of nodes. So it's going to be fast. And it's not going to use single threaded one way. No, it's going to scale it out and use all these machines that it has and all the servers that it has in its availability and execute those queries. Okay. So what I'm going to do is I'm going to show you, again, Visual Studio. I'm going to create a new tabular model. And I'm going to import data from SQL Server, although we also have a PDW down here. We're actually going to use SQL Server. And I'm going to connect to my database. We're going to use SQL Server authentication. I'm going to select NOAA again. I'm going to use my service account. It imported data. It's not too much data here, but it's just about the idea. So what I can do now is I can go into my tabular model. And from now on, we still are normal analysis services tabular models as we know it. What I can do is click on my model and swap it over to direct query mode is on. As soon as I do that and I deploy it, it will now automatically translate DAX into SQL and send that to the underlying data source and get data in return to it. I'm going to show you. So what I'm going to do is run a profiler trace against my analysis services. I'm going to select blank. And I'm going to select query begin, query end. And I'm going to select direct query mode. I'm going to run my profiler. Now I'm going to use Excel 2013. And I'm going to point to my database. For my analysis services, point to my local host. Choose my direct query PDW mode database. Press finish. Create a Power View report. This is the interesting piece. You cannot create pivot tables because pivot tables are not supported in direct query mode. You can only use Power View. It's creating a new Power View sheet. Now let's see if this works across half the continent. And so this is the database. I'm going to click on my population. And now it's going to create the sum of population for all the text files that are in the Hadoop store running a Redmond, and here we have the number. I can show you that what it actually does under the covers. Under the covers it does query begin. Power View send this query on the bottom. Evaluate rows, sum population, calculate sum to my tabular model. My tabular model now starts at the beginning. Okay, this is direct query. This is the SQL query that it sent to PDW. This is the query got returned 4 seconds later. 4 seconds later, query end, and that was it. So it translated DAX into SQL, pushed it down to PDW. PDW made it into Hadoop, and Hadoop returned the information. We got all the way back into Power View, and here we have the number. And with that was the last demo that I had. going to go back and show you a few of the related content that is here. It's going to be also pretty interesting for you, I hope. Dynamite data visualization in Power View in Microsoft Excel. So it shows you how to build the best Power View workbooks on the Power View reports on top of in the Microsoft Excel. Self-service business intelligence and governance. I think this session was just done by my colleague Kai, but it will be available online. Power Pivot in Excel 2013 in action, which gives you an overview of what you can do with Power Pivot in Excel 2013. Querying in DAX, which is also very interesting if you want to know more about querying in DAX. Using Power View with multidimensional models is a session that I do on Wednesday. And I will be a lot at the SQL Server booth, so if you have more questions, please feel free to drop by there. Or find me at Ask the Experts, I will be there. And please fill in your evaluations. I would really like to hear what you think about this session to improve what I can do for you in the future. We can do questions. Is there anyone with questions? Yeah?
One quick question. When you're bringing data into Tabular, is there a plan to make it able to update the column names for an entire table as opposed to one at a time? You know, because when I worked with Tabular several months ago, I renamed columns. It was a one-at-a-time operation, and after each rename, we would go and update the workspace. And it was kind of
So the question is there a way to do that? And actually there is. So the question is, not with the script, the question is if I change one column. Right now it's a little bit clunky. It starts doing all these operations in the back. What you can do is go in here and go into Model and say Calculation Options, Manual Calculations. In that case, it won't update the metadata. Yes. Yes. And then you can click on Calculate Now, and that will automatically calculate it. Yes. We do want to fix that issue.
I opened a Connect item on it. I'll have to post that.
Well, this is a workaround. It won't work. It won't work for everything. But
right.
Yes.
Yeah.
All right. I'll be here. Thank you very much. And I'll be here for more questions. So, thanks.